Jumping into question 5, we've been given a trig expression that we've got to simplify without using a calculator. So I'm going to tackle it bit by bit. Now this over here I want to set up for reduction. So I'm going to add 360 to make that possible. And after I add 360, I want to put the 360 in front of the minus x so that it starts to look like this. And then that's going to set me up beautifully to use my little cast diagram. Let's grab him while we're here. Alright, so the purpose of doing that was to set myself up for reduction, because that's now in the 360 minus quadrant. Now sine of 90 plus x is a cofunction that you must be comfortable with and know off by heart. So a trigger to recognize cofunctions is when you see 90 plus. Now that one is this cofunction over here. Sine of 90 plus an angle is just equal to cos of that same angle. So this over here will change to cos of x. Okay, now the sine 2 of x, it is a double angle. I do recognize that. But I don't know what to do with it just yet. So I'm going to sort the bottom out first maybe. And then afterwards I'll expand that. So let's leave the sine 2 of x there. Okay, now I'm going to sort out the bottom. 360 plus x, that's not in our reduction diagram. So what we're going to do is subtract 360 to make this normal. And 360 minus 360 is just 0. So this 360 essentially just disappears. And we're left with 2 cos x at the bottom. Okay, now we're going to start to tackle them individually once again. So tan of 360 minus x is inside the 360 minus quadrant. And in the 360 minus quadrant, only cos is positive, which means tan will be negative. So this will change into negative tan of x. This cos x is simplified as far as possible, so I'm just going to leave it there for the time being. And now the sine 2x, I'm going to expand with double angles. If you see 2x, that's your trigger to think of double angles. Okay, now sine 2x only has one double angle, so we're going to expand it with this guy down here. Okay, and when we expand it, instead of having a theta, we've got an x, so these will just become x's. So let's go ahead and expand it. And this 2 cos of x is simplified as far as possible so he can stay behind. Okay, now we're going to start to work through it individually again. Now this minus tan x, I smell an identity over there. I can change tan x to sin x over cos x, and you've got to know that off by heart. What I do to remember this trig identity, tan theta equals sine over cos theta, I say tan your socks. Tan equals sine over cos. SOC, socks. I know it's a bit weird, but it works for me. Okay, this negative will just stay in front of the sine over cos, like so. So that negative doesn't get affected as we discussed. This cos x will stay over here. Okay, now I can start simplifying this fraction. How satisfying. The 2's will cancel with each other because I've got one term over one term. So I am allowed to cancel. And additionally, the cos x's will cancel with each other. What a dream. So after that, we're left with sin x over 1, which is just sin x. Alright, this thing is starting to look a bit simpler. Now, I can also cancel things over here. And quite a nice way of seeing it is this cos x, I can put it over 1. And after I do that, I can cross cancel with these two fractions. So I can cancel the causes over here. And after I cancel the causes, I'm just left with minus sin x over there. And then I've got minus sin x plus sin x, which will give me a crispy little 0. It's like saying minus 7 plus 7. It's 0. Geez, all that hard work for a crispy little 0. Okay, you see, this question tested quite a lot of things. Reduction, cofunctions, double angles, identities, a bit of algebraic fractions at the same time. Okay, let's have a look where our 6 marks will come from. The first mark comes from the cos x through the use of cofunctions. The second mark comes from simplifying this into this by subtracting 360. The third mark comes from the tan x through reduction. The fourth mark comes from expanding the sine 2x to that, using your double angle identities. The fifth mark comes from changing the minus tan x to minus sine x over cos x with the use of trig identities that you should have learned in grade 11. And the last mark comes from the final answer of 0.